Hello everyone and welcome to this training session on probability concepts. My name is Vamsidhar. As a part of this session, let's look at the introduction to the world of probability now that we are clear on the basic concepts of statistics, especially the concepts regarding the frequency distribution and also something relating to the calculations relating to statistics like measures of central tendency as well as dispersion. Assuming those are the prerequisites, I am trying to move into the world of probability, which will help us in trying to assess the distribution associated with the data. What is the kind of distribution that is associated with the data? To have an understanding of that, it's better to get some level of confidence on the concepts of probability. And how is this statistics and probability linked? What we would be seeing as we move along is whatever we have discussed in statistics, we have created some kind of frequency distribution as well as relative frequency. And the relative frequency itself in a slightly sophisticated form will lead to the concept of probability. That is how we are finding the linkage between statistics and probability, right? The relative frequency distributions, and we remember we have done a lot of things with respect to the relative frequency distributions. We have got into finding out the mean of the data. We have looked at the standard deviations on the data. All those things will definitely be applicable even to the world of probability, because probability is nothing much different from relative frequency, which is again derived from statistics. With that as a base, we will try to get into understanding the basic concepts of probability. Here, the first thing we deal with when we talk about probability is uncertainty or chance. So there is some kind of randomness in the values that could be taken by a particular variable, and those kind of variables are called as random variables. For example, if I toss a coin, there is a randomness in the output. I may get a head or I may get a tail. That is what I am calling as randomness in the output. Or if I throw a dice, I am not sure whether I will be getting 1 or 2 or 3 or 6 or any of the numbers. 1 to 6, any number is possible. Such a kind of variable whose output is determined by chance. There is some chance that 1 may come, there is some chance that a 2 may come, and there is some chance that a 6 may come. So that is what, if any particular variable which does not have a definite outcome, whose outcome is random, where multiple outcomes are possible and there is a randomness associated to each of these outcomes, such kind of variables are called as random variables. And the different values that are associated with the random variables are called as the outcomes. When I throw a dice, I can get a 1 or a 2 or a 3 or a 6. So all these numbers are the outcomes of this random variable. And I would be interested in studying some or all of these different outcomes. I would like to analyze what is the chance of getting a 1, or what is the chance of getting an even number. So if at all I package one or more outcomes together, that is what I call as an event. Whenever we talk about an event, it is one or more possible outcomes bundled together, or zero or more possible outcomes bundled together is what is an event. Event is something which is of very interest to me, because I would like to know in probability, whenever we are doing something, what is the chance of getting ahead when I throw when I toss a coin 5 times? What is the chance of getting 3 heads? So the events are nothing but a combination of one or more outcomes, or even zero or more outcomes. That is what we are bundling as an event, and probability is always defined at an event level. If I try to correlate it with respect to our relative frequency, we have different class intervals, and we have a frequency in each of the class interval. Now, if I want to find out what is the chance that a particular selected value falls into this particular class, then all we are doing is a relative frequency of this class. And that is what boils down to the definition of probability. Out of the total possible values, what is the chance that that particular value lies within this particular class interval? So that's how the linkage is occurring. And so when I'm saying the events, that is the one which is of very important to us. That is the one we would like to track. That is the one for which we want to find out the probability. When I say P of A, it is nothing but what is the probability or the chance of a particular event called A occurring. The event A is nothing but the chance of seeing a set of outcomes, right? So that's where when we define events, when I take two events together, they can be mutually exclusive also, which means if A occurs, then B cannot occur, or vice versa. If a tail occurs, then head cannot occur on a throw of a die or a throw of a coin. If a 1 occurs, probably a 3 cannot occur on a throw of a dice. So those are the ones which are typically called as mutually exclusive kind of events. And as far as the events are concerned, I also need to understand a term called exhaustive events. What do I mean by exhaustive event? All the possible outcomes, if they are included as a part of any one of the event, if a particular set of events taken together, they include all the possible outcomes. Let's say if I say event A is getting an odd number in a throw of a dice, and event B is getting an even number on the throw of a dice. So when I take event A as well as B together, then all the possible values are coming, all the possible outcomes, because event A will talk about getting values 1 comma 3 comma 5. Event B will talk about getting the values 2, 4 and 6. Now if I take these two events together, then the entire set of all possible outcomes is being covered. Such kind of events, such combination of events is what is described as exhaustive events. And whenever we talk about the word probability, as I have already said, it is something similar to relative frequency of statistics, or a formal definition of probability is always the percentage of favorable outcomes, whatever we want to track, the percentage of the favorable outcomes as a percentage of the total number of outcomes. If I understand this, then lot of questions relating to probability can be solved. It is nothing but the relative frequency of that particular outcome. So as long as we are clear on linking these two concepts, we can solve good number of problems associated with probability also, once we have an understanding on solving the questions with respect to the statistics and frequency distributions. Now there are three ways in which people define the probability, though the broad definition is favorable outcomes by total number of outcomes. One way of deciding the probability is based on reasoning and logic, which is what is called as a priori probability. Now let's say I am throwing a dice. There are 6 possible outcomes. So if I assume that all the outcomes are equally possible, then the probability of getting a 1 when I throw a dice is simply 1 out of 6 because I am making a reasonable logic that the die is an even dice. Then all 6, there are 6 possible outcomes and all of them have equal chance. So I am defining the probability of getting a 1. I am not observing the data here. I am using a mere logic, and based on the logic I am trying to find out the probability. Favorable outcomes is 1 out of the total possible outcomes of 6, and that's where I am saying the probability is 1 by 6. So such kind of definition is what is called as a priori probability. Sometimes we observe the past data, and let's say in the past data I have observed if the question is what is the probability of a rain in a particular day, probability of raining on a particular day. Now I cannot say the two possibilities as rain and no rain, and I cannot say 1 by 2 because rain and no rain are not equally likely. So I cannot use 1 by 2 as the probability there. That reasoning can be applied only if I am fairly reasonable about the equally likeliness of the event. So here I may observe the past data. Okay, in the last year, out of the 365 days, probably if I have collected the data saying 25 days there was a rain. So what will I do? The probability of raining on any particular day is 25 by 365 because the total number of possible days are 365. Out of that, the favorable days are 225. So the probability of raining on any particular day is 25 by 365. If I derive the probability from this kind of a perspective, we call it as empirical probability. So one, I can use my logic, reasoning, which is what boils down to priori probability. 2, I can do the calculations from the previous data by observing, and based on that arrive at the definition of probability, which is called as empirical probability. And 3 is subjective. I just use my gut feeling. There is a 60% chance that the prices will go up tomorrow. There is no logic to it. I have used my gut feel, I have used my subjectivity. So I have not done any big logic there, or nor I have used the past data. Based on my gut feel, based on my subjectivity, I am assigning some kind of probability or a percentage to it. Such kind of probability is what is called as a subjective. So probability can be defined from these three possible dimensions, right? Depending on which definition suits to our business requirement, we would be using that appropriate definition and then calculate the probability accordingly. Sometimes people talk about probability in connection with odds for or odds against a particular event. Whenever I talk about the odds for is 1 is to 3, which means if there is one chance of occurrence of an event, there are 3 chances of non-occurrence of the event. So the total events look like 4. Out of that, 1 is a possibility. So if I have to convert it into probability of occurrence of that event, I'll say 1 by 4. The simple way is, if at all the odds are given, so I will take the odds infer divided by the total number of odds. That is what will become the probability. And from the probability, if I want to go for odds per, take the numerator as it is and take the difference between the denominator and the numerator, which will make this as the odds per. And odds against is the not occurrence of A will come first and occurrence of that event will come to the next. So 3 is to 1 will go as odds against the event. 1 is to 3 is called as odds for the event. 1 by 4 is the probability of occurrence of the event, and 3 by 4 will be the probability of non-occurrence of the event. All these things have to be linked and understood, because in some cases we would be seeing the word called odds for and odds against instead of actual probabilities. So even if they are there, we should be able to convert them into probabilities using this kind of a relationship. Then, couple of things we have to remember with respect to probabilities. Any event, the probability will always lie between 0 and 1 itself, because the simple definition is favorable outcomes out of the total outcomes. Favorable outcomes can never be greater than the total outcomes. There is some mistake with our calculation if such kind of outcome occurs. So we can easily conclude that the probability value will always lie between 0 and 1, and both of them are inclusive. 0 means it's a completely, definitely impossible kind of an event, and 1 means it's a definite possible kind of an event. So both are definite, but anything lying between 0 and 1, there is some kind of chance associated, some kind of uncertainty associated with it. And if I am taking mutually exclusive as well as exhaustive events, which means if A occurs, B should not occur, that is mutually exclusive, and A and B put together should give out all the possible events. That is what we are calling all the possible outcomes. That is what we typically call as mutually exclusive and exhaustive events. And what is being said is the sum of probabilities of all the mutually exclusive and exhaustive events should be equal to 1. And if two events are mutually exclusive, which means if A occurs, B should not occur, and vice versa, then the probability of both those events occurring together is 0, right? Because if A occurs, B cannot occur. That's the reason they are called as mutually exclusive. If that's the case, both of them occurring together, there is no chance at all. It's a definite no. That's where we are calling it as 0. Then couple of more things that we have to understand while talking about probability is, in some cases we see if I take two events A and B, there is a chance that the probability of B depends on A, depends on the outcome of A, depending on whether for example, if I say the probability of a particular year to be a good economy is 60%, probability of a bad economy is 40%. Now I'll take one more event called unemployment. Probability of unemployment. Now this unemployment, in a good economy the unemployment could be different. In a bad economy the unemployment could be different. Unemployment is not completely independent of the economy, right? Because if the economy is doing good, probably the unemployment chances are much lesser. If the economy is bad, the unemployment chances are much higher. So what we are saying is one event, which is the chance of unemployment, will depend on whether the economy is good or bad. There is a 60% chance that it will be good, there is a 40% chance that it will be bad. But unemployment as such, because it is depending on the economy, we call that kind of a probability, where we are not looking at probability of occurrence of an event called unemployment. We are talking about provided the economy is good, U given G, or we'll say probability of U given P. Given that the economy is good, what is the probability of unemployment? Probably I'll say 25%. Given the economy is bad, what is the probability of unemployment? I am saying 50%. So what we are saying is, if one event is depending on the other event, then we always express it in the terms of conditional probability. Conditioning to this outcome on condition that the economy is good, or on condition the economy is bad, I am finding out the probability of unemployment. I am not looking at probability of unemployment in isolation, but in dependence with the economy. Such kind of probability is what we are calling as conditional probability, especially if there is a dependency between the two events. Then the chance of one event occurring as a result of the other event already occurred. If assuming that the economy is good, what is the chance of unemployment? That is what we call as conditional probability. We'll use this conditional probability in some of the calculations as we move along. So we have to understand this one more term, because in real world we'll use this concept in a large manner, because two events in large number of cases, they may be dependent on each other, and wherever the dependency is existing between the two events, I should not look at the events in isolation or independent. I have to use the conditional probability relationship between them. Now, if I take two or more events together, how do I join two or more events? And that joining of two or more events, and see, I don't want to look at one event in isolation. In most of the cases, I may have to look at the chance of either two events occurring together, or multiple events occurring together, or at least one event occurring, or given multiple conditional probabilities, what is the unconditional probability? These are the three scenarios that I may be more interested in. Looking at two or more events together, if I want to find out the chance of all events occurring together, all the events occurring together, I use something called multiplication rule of probability. For example, if I want to find out what is the chance that the next 2 years, what is the chance that the next 2 years the unemployment is low? So what I want is probability of the first year unemployment being low, and given that it is already low, see, if it is not low in the first year, then there is no point in looking at the second year itself. So given that the first year is already low, what is the probability that the unemployment is low in the second year? So that is what I am using as the multiplication rule. If at all I want to find out for the probability of two different events and both of them occurring together, we call it as a multiplication rule of probability, and we represent it as P of AB, or sometimes people also write it as P of A intersection B. Intersection B means both the events occurring together. The way it is written as, find out the probability of one of the events occurring, and means multiplication in the probability language, and given that A has occurred, what is the probability of occurrence of B? Or the same thing can be written as, find out the probability of B occurring, and given that B has already occurred, what is the chance of occurrence of A? This is what is called as the multiplication rule of probability. And just as a small corollary here, if A and B are independent, it hardly matters whether A has occurred or not, whether the information A has occurred is known or not. In that case, what happens is P of A intersection B will directly become only P of A into P of B. If there is no dependency between the events A and B, then given A has occurred has little importance, because B will occur irrespective of what is the result of A. So the same way in the next line, given B, what is the probability of A? Because if they are independent events, then obviously the occurrence of B does not have any kind of an impact. So I'll directly go with P of A itself. So whenever I want to look at two events occurring together, we depend on the multiplication probability rule. Then we also look at an addition rule which talks about at least one event occurring out of A and B, let both of them occur or at least one. So in the next 2 years, what is the chance that at least 1 year the unemployment is lower? So that is what I say, one or two, or sometimes people write it as union, which means either one or two or both. So that is where we use the formula called P of A union B goes with P of A plus P of B minus P of AB, and P of AB is something which we have found out using our multiplication probability rule. So using that formula I can find out what is the chance of at least one of the events occurring. So probably you should convert into the business scenarios and then look at what is the chance of at least one of the events occurring. And sometimes what happens is we also talk about, let's say there are I'm having some of the things like probability of unemployment given the economy is good is 0.25. Probability of unemployment given the economy is bad is 0.5, and the probability of a good economy is 60%, probability of a bad economy is 40%. Now if I want to find out the unconditional probability of unemployment, which means here unemployment, there are different probabilities under different scenarios. So if I want to find out the overall probability of unemployment, that is where I resort to the total probability rule. What I'll take is, I'll take all the possible conditional probabilities. So I'll take P of U given G and multiply it with P of G. What is the chance that a good economy will be there? And if it is a good economy, what is the chance of unemployment? Similarly, I'll take probability of unemployment given bad multiplied by what is the probability of a bad economy. Now if I do that multiplication, U given G is 2.25 into G is 0.6, so which will take it to 0.15, plus U given B is 0.5, P of B is 0.4, so multiplication will take it to 0.2. Overall, I'll say that there is a 35% chance of unemployment. The probability of unemployment in any given year is 35%. Out of that probability, if the economy is really good, it will be only 25%. If it is really bad, it can go up to 50%. But overall unconditional probability of unemployment is 35. So wherever we have the possibility of multiple conditional probabilities coming up, under different scenarios, different probabilities for the same event are cropping up. If that is the scenario, if I want to find out the unconditional probability of that specific event, I will depend on this total probability rule. So we have to be comfortable. You can practice some of the numericals which are given. Simple way to understand is, one, multiplication means both the events occurring together, multiple events occurring together, at least one event occurring out of all the possible events is an addition rule. And when I talk about the unconditional probability given different conditional probabilities, we'll try to resort to the total probability rule. These are the three major rules. If I am able to understand, then we can combine as many events together, and we can try to find the impact of various calculations. And whenever we are talking about a multiplication rule, the other word for the multiplication rule is also a joint probability. So this is what is the expression associated with the joint probability, because we have said P of A intersection B is equal to P of A multiplied by P of B given A. And in case the events are independent events, P of B given A will directly boil down to P of B, because it is nowhere dependent on A. So whenever we talk about n independent events, the probability of all of them occurring together is nothing but the multiplication of their individual probabilities. That's one more thing we have to be comfortable with in terms of understanding the probability fundamentals. So whenever we are talking about the outcome of one of the events not influencing or is not influenced by the other event, we are calling those kind of events as independent events. So in any independent event, we'll see this kind of a relationship. P of x given y will become P of x, or P of y given x will become P of y, because there is no dependency between x and y. Now, there is one more key event, key theorem to understand from the world of probability, which is called as Bayes theorem. This is derived from a very simplistic scenario, right? We have used P of A intersection B is equal to P of A into P of B given A. Similarly, we also said that this is same as P of B into P of A given B. Now equate these two terms. P of A, because both of them will point out to P of A intersection B. P of A multiplied by P of B given A is equal to P of B multiplied by P of A given B. Now from this I can very well find out P of A given B, take it to the other side, which gives me P of A into P of B given A divided by P of P. And this is what is called as a Bayes theorem. What it is saying is, look at this. Given that A has occurred, I want to find out the probability of A given B has already occurred. Then what it is saying is, try to find out, take the probability of A in isolation, probability of B in isolation, and multiply it with the probability of B given A, which will result in updated probability for A under the influence of a new information called B. So what it is saying, divide the probability of new information given event by the unconditional probability of new information. Unconditional probability of new information is P of P. Probability of new information given event, which is probability of B given the original event which is already occurring A, and multiply the result with the priori probability of the event, which is P of A, the existing probability of A. So what we are talking of here, if I know that something is the probability of occurrence of A, and which is before the occurrence of B. Let's say I am saying the occurrence of unemployment is 40%. Now I want to find out the occurrence of unemployment given a new information, which is the economy is bad. Right? Initially I know that the probability of unemployment is 40%. Now I was asked to find out what is the probability of unemployment given the economy is bad. So new information has come up and I want to find out the updated probability of this. So for this, what we are saying is, find out what is the unconditional probability of the new event. What is the probability of a bias in the economy, badness in the economy. Let's say I am saying 50% is the chance of badness in the economy. So what I'll do is this 0.4, I'll divide it by 0.5. Then I'm also finding out what is the probability of bad given unemployment is already existing. The other way, if the unemployment has already existed, what is the chance of the economy being bad? Let's say if I am getting that to be around 0.8, then what we are saying is this particular probability 0.4 by 0.5 into 0.8, around 0.6 or something, is what is the updated probability. In case the economy is bad, the unemployment is going to be around 60%. So what we are doing as a part of Bayes' theorem is, initially I have an unconditional probability of existence of an event, whereas I'm trying to find out the updated probability of that same event upon the arrival of the new information. So for that, I am dividing first of all by the unconditional probability of the new information and multiplying the total with the probability of the new information given the existing information, probability of occurrence of new information given the existing information, and using that I am trying to find out the updated probability of the event. This is something which is used in a lot of applications, but the easiest way for me to remember is, if I know P of A, B and P of B given A, I should be able to find out P of A given B and vice versa. So there is a linkage between these four elements, and if I have three of them, I can very well find out the fourth one. That's a typical way I can look at the understanding and interpretation of the Bayes' theorem. And towards the end, we also discuss about small counting related topics, because as we move along and as we talk about various types of distributions and shapes in our next few chapters, there is a lot of usage of the terms from permutations and combinations. So here we need to, so whenever we talk about n items present, out of that some r items need to be picked up, but the order of picking up is very important. The order in which these r items are picked up is very important. Then we call that pickup procedure as a permutation. But out of the n items, I just need to pick up r. In whatever order I pick up, it is unimportant, it's immaterial. Then I call that as combination. One thing we have to understand, what is the difference between a permutation and a combination? From a definition standpoint, if I have to pick up r items from a set of n items, and each of them, the order in which they are picked is very important. Probably if I have to rank 3 people out of 20 people, it's just not picking up 3 people, but I have to give them the rank. The order in which they are picked also is very important there. Then I call that to be a permutation. Whereas if I just need to pick 3 from 20 to give an award, and all of them will get the same kind of an award, then the order in which they are picked, the ranking does not matter in that kind of an example. Then we call it as combination. And what it is said is, I need to know in how many ways they can be picked, because probability has something, probability calculations have more, if I have to find out how many possible ways are there, because when we talk about the definition of the probability, we were using the word like number of favorable outcomes divided by the total number of outcomes. So if I want to know what is the total number of outcomes, in some cases it's not easy to count. right? I have to pick 3 people from 20 people. In how many ways they have to be picked? They can be picked. Becomes very difficult for me if I have to start counting them separately. That is the reason we depend on the features like permutations and combinations. Wherever I need to pick up people where order is important, I depend on permutation. Where order is not important, I depend on combination. So the permutations are generally represented as NPR, combinations are represented as NCR. And the number of ways will be simply nothing but n factorial by n minus r factorial. What is this factorial? Right from n, if I say n factorial, it is nothing but from n up to 1. You decrease the values and do the multiplication. N into n minus 1 into n minus 2 into so on up to 1. Which means when I say 4 factorial, it is nothing but 4 into 3 into 2 into 1, which is 24. That is what we call as factorial. Any number that is multiplied up to 1 on a decreasing fashion is what we are calling as factorial. So in NPR, if I want to find out number of arrangements of R objects from N objects, this works out to NPR, which is n factorial by n minus r factorial. And when we have to talk about combination where order is not important, it works out as n factorial by n minus r factorial, but an additional r factorial in the denominator. So just as a mathematical relationship, it can also be written as NCR is equal to NPR by R factorial. This is a very important mathematical relationship, but the key thing we have to be comfortable with here is when do I use a permutation and when do I use a combination. In my business scenarios, if I have to pick up R items out of the N where order is very important for me, then I'll depend on NPR. Where order is of not important to me, I will depend on NCR. So that's whatever is the number of possible ways, whether it is for favorable or total. In the calculation of the probabilities, we use these things a lot. So we have to be very comfortable with the understanding of the concepts of these two items also. So as a summary of this chapter, we have started with the basic definition of probability, then focused on the different ways in which probability can be defined, the subjective, the empirical and the priori models, and then compared probability with the odds, then used the different theorems of probability, the addition theorem, the multiplication theorem, as well as the total probability rule. Then we have distinguished between conditional probability, which exists for dependent events and independent events, and finally ended up with the Bayes theorem. And towards the end, discuss the counting specific rules because we would be using them as a part of computation of the probability. So permutations and combinations, the number of permutations possible, number of combinations possible, the formulas associated with them. And as we move along in our later chapters, when we have to discuss about the different aspects of probability, we would be using them as required. Right? I hope all these basic concepts are clear to you. In case you have any further queries regarding these, please feel free to contact me on the phone number that is mentioned below, 984801223. You can even drop in an email at vamsidhar@pacegurus.com. And I request all of you to visit my website www.pacegurus.com to find out the latest updates in the areas of training and consulting in finance, analytics, and statistics using the tools like Excel, VBA, and SPSS. I hope this session has helped you in understanding the world of probability. Thanks a lot for listening to this session. Thank you very much.